This is the first mini lecture for section 2.4 of the textbook. It corresponds to section 1.4 of the syllabus. This section is about multiplication and division. We're going to begin with multiplication. And it should come as no surprise that multiplication is just repeated addition. So when we write down a times b, what we're saying is we want to add b to itself a times. That is provided a is non-zero. If a is 0, then we just say 0 times b is equal to 0. So again, it's repeated addition. A times b is simply b plus b plus b and so on, where we're adding it to itself a times. So, for example, 3 times 4 represents the sum 4 plus 4 plus 4, which is 12. Notice, on the other hand, that 4 times 3 represents a different sum. It's 3 plus 3 plus 3 plus 3, which is 12. So you get the same answer, but they're different sums. 3 times 4 is 3 fours. 4 times 3 is 4 threes. The answer is the same, but the sum is different. The order of the factors matters. Okay, this is important to observe when you're teaching. If you want to illustrate something like 3 times 4, it has to be illustrated in the correct way. Otherwise, you're going to confuse students. Because although it might be obvious to you that these are the same thing, it will not be obvious to them. And frequently, you'll have assignments where the students have to represent multiplication as repeated addition. And typically, they're going to be expected to know the difference between those two things. Understanding multiplication is more than just getting the answer correct. You have to understand the process. That's important for a lot of things that come later in mathematics. Okay, there are 6 different word problem models for multiplication. The first is the set model. 4 girls are going on a picnic. Each is bringing 2 apples. How many apples will they bring all together? Let's draw a little picture. This represents the repeated addition model. Notice that it's 4 groups of 2, which means it's 4 twos, which means we're representing 4 times 2. So this represents 4 times 2, which is 2 plus 2 plus 2 plus 2, which of course is 8. Okay, but the order of the factors matters. Remember that. If I were to ask you to illustrate 4 times 2, and you were to draw or explain 2 groups of 4 instead of 4 groups of 2, then you wouldn't get it correct. Okay, the second model is the measurement model. Joe likes to go jogging every weekday. If she jogs 3 miles a day, how far does she jog in 5 days? So let's draw a number line. Remember, always start your number lines at 0. Okay, and what we're trying to illustrate here is 5 groups of 3. So each arrow represents 1 day. There's 3, plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. And this illustrates 5 times 3 equals 15, not 3 times 5. Okay. Make sure to make note of that. Now, of course, we know that 3 times 5 is 5 times 3. When you're trying to illustrate multiplication as repeated addition, it's not really obvious that those are the same. But some of the other models are less sensitive to that. So they make it a little bit more obvious that, yeah, these are clearly going to be the same thing. An example of that is the array model. The array model comes up whenever you are arranging objects in rows or columns or stacks, things like that. So look for those keywords, rows or columns or stacks. In this array model question, Diego is planting a tomato garden. He wants to have 4 rows of tomatoes with 6 plants in each row. How many plants will he have in all? So 4 rows of 6 each. I'll just draw a little tomato for each row. So there's the first row. In the second row, and the third row, and the fourth row. And this is 4 groups of 6, so it represents 4 times 6. Okay, but what's nice about the array model is it's more obvious that that's the same as 6 times 4. So all I have to do is turn the paper sideways, and there's my 6 rows of 4. All right, that was the third model. The fourth model is the rectangular area model. It's kind of similar to the array model, except here, instead of having objects that we're lining up, we're really starting with the big shape, and we're dividing the shape up. So here, Tina is covering a small patio with tile. If each tile measures 1 foot square, and the patio measures 3 feet by 4 feet, how many tiles will she need? So the idea here would be to begin by drawing the rectangle that is to be divided up. Okay, so 3 feet by 4 feet divided up into 12 squares. So you see that 3 times 4 is 12. This is another model where it's easy to see that it's the same as 4 times 3, because I can just turn the paper sideways, and there's 4 times 3. Okay, the fifth model is the multiplication tree model, which usually applies when you have some kind of process that you can complete in 2 steps, and you're trying to figure out how many different outcomes are possible. So here, Janie wants to hang 2 flags of different colors on a flagpole, one above the other. She has red, yellow, green, and blue to choose from. In how many ways can she do this? So you can think of this in 2 steps. She hangs, let's say, the top flag, and then she hangs the bottom flag. When she hangs the top flag, she can choose from red, yellow, green, or blue. So I'm going to draw a little tree with 4 branches. Red, yellow, green, blue. Here's our branches. It's an upside down tree, I suppose. Okay, and then the colors are supposed to be different. So whichever color she chose for the top flag, she now has the 3 other colors to choose from for the bottom flag. So if she chose red first, she could choose now yellow, green, or blue. If she chose yellow first, now she could choose red, green, or blue. If she chose green first, now she could choose red, yellow, or blue. And if she chose blue first, now she can choose red, yellow, or green. And so you see each of these little paths to the bottom represents a pair of choices. Like this is red above and yellow below, red above and green below, so on and so forth. So how many different choices were there in all? Where is 12? And this represents 4 times 3. So there's 4 ways to make the first choice. And then once she's made that choice, there's 3 ways to make the second choice. That means there's 12 ways to do the choices in all. Okay, and last we have the Cartesian product model. The word Cartesian is kind of, a funny word that you might have heard in algebra class. Let's not worry about it right now and just talk about the model, and then we'll see why it applies here. So when you do a Cartesian product model question, you're always trying to figure out how many pairs can you form from 2 groups of things. Okay, in this problem, we have this ice cream stand that sells ice cream in each of 3 flavors with a choice of 4 toppings. And we just want to figure out how many ways can you order 1 flavor and 1 topping. So in other words, how many ways are there to pair off these 2 groups of things? And let me use set notation to write out the flavors and toppings. The flavors, say it's chocolate, vanilla, and strawberry. We'll use capital letters for those. And then the toppings, we've got sprinkles, nuts, coconut, chocolate syrup. I'll use the letter Y for that. And then we're just trying to figure out how many ways are there to pair these off. And yeah, I can just make an array, basically, of all the pairs. We've got chocolate and sprinkles, chocolate with nuts, chocolate with coconut, chocolate with syrup, vanilla with sprinkles, vanilla with nuts, vanilla with coconut, vanilla with syrup, strawberry with sprinkles, strawberry with nuts, strawberry with coconuts, strawberry with syrup. And there's 12 pairs in all. And what we've illustrated here is that 3 times 4 is 12. Okay, so a Cartesian product of 2 sets is just a set of all the pairs of elements of the 2 sets. And you've heard this word Cartesian probably in an algebra class when it's used to refer to the xy plane, which is also called the Cartesian plane, because it's the set of pairs x comma y. So you can think of these as like coordinates that we're forming from the 2 sets.